Hello, my friends. Welcome to this new section on now decision tree regression. So we're about to tackle a new practical activity where we will all learn together how to build the decision tree regression model. You will see that it will be super easy based on what we did before, with all the feature scaling and inverse transformation of the SVR. Now we won't have to apply feature scaling, and therefore we will just smash this. All right? Are you ready? Are you ready to start? Before we go into this part 2 regression folder, let's just make sure that everyone here is on the same page. I give you the link to this folder just before this tutorial, so you just have to click the link, and then now we should all be on the same page. So we're going to go into part 2 regression and then section 8 decision tree regression. We're almost at the end of the regression part. Congratulations for the great progress you've made so far. And now we're going to go, of course, to Python in order to find our files for this section. So there are two files here: the Python implementation of the decision tree regression model in IPYNB format, which you can open with either Google Colab or Jupyter Notebook, and our same position salaries dataset containing that same data of the previous company, showing the different position levels from 1 to 10, corresponding to business analyst to CEO, and the corresponding salaries from $45,000 to $1 million per year. All right, so this time we're going to train a decision tree regression model to understand the correlations between these two features. However, I have to say something important here. The decision tree regression model is not really well adapted to, these simple data sets, with only one feature and the dependent variable vector. You'll see what I mean by that at the end, on the visualization graphs. But having said that, I would like you not to worry, because the implementation of the decision tree regression model we're about to build will still work on any other data sets, with several features. Here we have one feature, but the code we're about to make will work for data sets having any numbers of features. All right, so even if the results won't be beautiful in the end, well, you will still be able to use this decision tree regression implementation on your other datasets, even if they have hundreds of features. But then make sure to add some data preprocessing tools if needed. For example, if your dataset has some categorical data or missing data. But you don't have to apply feature scaling for decision tree regression, and neither for random forest regression, which will be our next model, in the next section. All right, so that's the important thing I wanted to say here. And now we're going to start our implementation by double-clicking this file here, which you can either open with Google Colab if you like, Google Colab like me, or Jupyter Notebook. All right, so choose your favorite. And now let's open Google Collaboratory. It is opening the notebook. And here we go. That's the whole implementation. All right, so as usual, now we're going to create a copy of this notebook, because this is in read-only mode, which means you can't modify it or recode it. So we're going to go to File here and then click here, Save a Copy in Drive. And this will, as you can see, create a copy of this notebook on which you will be able to recode on it, re-implement this decision tree regression model. Perfect. So now, the next step, we're going to delete the code cells, but since it is the third time we actually work on this position salaries dataset, and of course, each time it's the same two first steps of the data preprocessing phase, importing the libraries and importing the dataset, well, this time we won't re-implement this. We will just leave them and not delete them. So we will just delete all the code cells from here, from the step training the decision tree regression model on the whole dataset. All right, so let's do this. Let's start by deleting this one, because we will re-implement it together, then this one, and now this one. All right, perfect. Also, you can notice that at the end, we will only visualize the decision tree regression results in high resolution, because you will see, and I will show this to you, that the decision tree regression results in low resolution, without applying the grid solution, will absolutely not make sense. And I will explain that at the end of this section.